Okay, so next up is Ciaran Nevin from Old Cabra Road. So Ciaran, I'm going to try and bring your presentation up if you just want to introduce yourself.
Great, thanks. And hello, everyone. It's great to see such high turnout. So yeah, I have an introductory slide here about myself within this. The reason being, I suppose I'm not your typical resident in that I'm the son of a builder and spent all of my youth on building sites, etc. So a lot of the work that I've done is pretty extensive on the house and mostly done myself. So on the cost side, for example, I wouldn't be the most helpful here today, but I can talk you through the experience of putting in a heat pump and the things to think about, the challenges and the benefits, etc. So I think we can skip the content slide. I'll be coming to it anyway. And I don't know if that has moved on. Yeah, so just to say, yeah, as I said, that I worked as an engineer and more recently as an economist, focusing on efficiency and energy, etc. So my finger will be relatively on the pulse in this whole area. And so even with that, I suppose the point is that I still would do things differently if I was doing the house all over again. So talk to as many people as you can and get as much advice as you can before you set out on any project, I suppose is the first thing I'd say. So a bit about heat pumps. So I think the first thing to understand about a heat pump is that it's not new technology. Your fridge is a heat pump. So what your fridge is doing is it's taking heat out of the box that is your fridge, and it's heating the room through the fins that are on the back of the fridge. So a heat pump is working in the opposite direction, essentially, by taking the heat from outside and bringing it inside. And that can be hard for people to get their heads around. Some people either think that essentially all you're doing is using electricity to heat your home, and others assume that there's some other fuel that's involved. But it's really important to understand that the electricity is only working the mechanics of the system. It's only moving the fluid around through the system and moving the fan. But the heat is actually energy that's been taken from the ambient air outside. And that technology, as I said, my dad was a builder. He's retired now, but would have been quite innovative in his time. One of the first to use timber frame homes in Ireland, for example. And yet, when he was on site and I was away for a few days, he asked my electrician to wire up the house for a boiler because he had no faith that this heat pump would work with an Irish winter. And so when I got back, I had noticed that it was wired up for a boiler and a heat pump. So I've never needed the boiler since, just to say. But I guess it's just the point. This technology is a little more difficult for people to get their heads around, but it does work. So we can move on to the next slide. Some key points to grasp about it. Yeah, so it's not using electricity. So don't confuse this with like electric radiators or storage heaters or anything like that. The notion behind the heat pump is that the electricity use that you put in, so say you use 1 kilowatt to run the heat pump, you'll get usually around between 2 and 4 kilowatts of heat for that input. So you're actually, you're getting more out than you're putting in because you're taking that heat out of the ambient air. They work at lower temperatures than gas or oil boilers. So this means that if you're using them with radiators, for example, the radiators will never be hot to touch. And this also means then that they're heating a home over a much longer period. So the system is running for a long period, and it holds the home at a steady temperature. So that's why insulation is so important, because if your home is leaking a lot of heat out through its walls or through the roof, etc., the heat pump essentially can never catch up. So it's constantly running, and that's where people end up with enormous electricity bills from trying to run these systems. So really what you should be doing is allowing it to heat your home slowly and steadily. You use it without a timer, so it's not like, again, typical central heating where you put on the heating for an hour in the morning and an hour in the evening and then suffer through the gaps. Here you leave it on, you leave the system basically armed, and it will turn on and off based on the change in temperature in the house. So for example, if you have a particularly sunny day and the sun is belting in through the windows, the system will stay off because it will have picked up that the temperature is being sustained by the heat coming through the glass, and then obviously at the first sign that temperature is dropping, the system will kick in again. So, but if you have a poorly insulated home, as I said, the temperature is much more likely to fluctuate. And that's when your system is constantly kicking in, which means that you're running up very significant electricity bills. And so I suppose that what I'm getting at here is that really you shouldn't be thinking about the heat pump as your first step. And I think Fergal made that point very clearly with his that sort of pyramid or hierarchy of where you should start in terms of work on the house. Every house will be different as well, so the system will be sized depending on your house size. So much like the solar panels, for example, you get different quotes, and it's important to go through that process and get a few quotes. Also, always worth considering getting quotes from a little bit further than, say, the local area, because you might get better rates, for example, from providers that are further out of town. So that's here we go. Yeah. So my house was built in 1935, precast concrete slabs. The house was extremely cold and damp. The suspended wooden floors were rotten on the ground floor. Single glazed wooden windows, they were falling apart. Not a stitch of insulation anywhere. It was an F-rated home, and so complete gutting was required. And I just have a picture there of the lorry arriving with the insulation for the house, just to show that it was a very significant amount of work that was required. And so that presented the opportunity to put in the heat pump, I suppose, is the point that I'm making. I would not have jumped straight to putting in a heat pump. The priority is to get your home insulated first. And because of the extent of the work that was required, for example, the floors being rotten and having to be replaced on the ground floor meant that was an opportunity to put in underfloor heating. And so when you can use underfloor heating with the heat pump, it's particularly efficient because essentially your whole ground floor becomes a radiator, which is releasing at a low temperature a nice steady heat, which makes running a heat pump very efficient. So I just have some photos to show exactly what goes on there. So there would, I think one of the previous, might have been Maria, mentioned that she had suspended wooden floors on the ground floor and that they were drafty. So when you pull up those wooden floors, there's a cavity. In my case, it was about almost half a meter of a gap down to another concrete floor. And so I filled that with hardcore and then put down 100 mil of insulation, which is what you can see on the left. And then after that, the underfloor heating pipes are laid out. So that's what forms the large radiator. And then a new floor is poured. And this stuff it looks like mushroom soup. And it sets within a few hours, but it takes weeks to dry. So you're talking about a huge job to do something like this. This isn't the sort of thing you can do while you're living in the house. But it is what makes a heat pump particularly efficient to use if you can do it. So then another consideration is if you're using underfloor heating, for example, it doesn't make sense to go and put wooden floors down on top of that, because the wood actually insulates the floor again and keeps the heat out. It keeps the heat from transferring into the room. There's a photo of the fan unit. So I think somebody asked previously if they're noisy. If they're fitted correctly, they shouldn't be noisy. The noise comes from the vibration of the system. But obviously it is a mechanical unit. So, in 10 years' time, perhaps bearings might need to be replaced, depending on usage, for example, because it might start to get rattly. But what I will say is that the cold air that comes out of it is absolutely freezing. And so you don't want that thing pointing at your back door, for example, where every time you have to go out, you're getting blasted with cold air. So that's just something to consider. And then inside there's a cylinder unit. So this is the equivalent to what would have been an old style hot press. So it's about the size of a fridge freezer there, and that's where your cylinder is within that unit, and all of that is managed by the system itself. So I haven't adjusted the heating controls since this went in almost a year ago now. It just runs by itself and manages everything. So day-to-day operation, don't know how I'm doing for time. But essentially, there's a stat like this.
About a minute left, I'd say.
About a minute, that's perfect. Yeah. A stat like this in each zone. And as I said, I haven't adjusted them. I've just forgotten about them, and it manages everything itself. That's the best way. If you're constantly adjusting the settings, then the heat pump is constantly trying to adapt, and that means that it's using electricity, which is not ideal. So when you have underfloor heating, for example, you could actually, if you have the night rate electricity, you can actually run that to heat your home through the night, to heat the floor through the night, and the floor will actually give off that heat through the day, much like a storage heater would have done in the past. So I can move on from that. So some of the challenges: investment in insulation is almost always required, particularly in houses in Cabra, given their age. Average age is probably close to 100 years for houses in Ireland. Some rewiring may be required depending on how old your electric circuit is, because of the load that a heat pump can place on the system. What happens in a power cut is just something to consider. How do you heat your home if there is an electricity outage? So that's where the likes of solar comes in as a backup. Space for internal and external units is something you need to consider. Also, you'll need to get an electric oven and hob. Otherwise, you'd be relying on, you'd be paying for a gas service charge just to have a gas hob, for example, which wouldn't make sense. But the benefits are fantastic. So you are insulated from gas, oil prices, because only a small share of electricity costs come from, about 40% relate to gas. You have free operation if you've combined it with solar and PV and a battery. It is much more comfortable, better quality of life. You just forget about it and everything is nice and steady temperature-wise. And it's also a good way of making use of solar, surplus solar capacity, or the night rate electricity, as I said, if you have underfloor. And finally, there's just a few links there that I've included, but basically the SAI, Electric Ireland, and YouTube is full of videos about heat pumps. You'll knock yourself out better than any Netflix. So that's really it, and happy to take any questions later on.
Cool. That's brilliant. Thanks.